Okay, so if you've done physics, I don't know if anybody's done physics, but you're probably familiar with vectors. If not, it's probably new. So a scalar quantity is a quantity that just has a magnitude, meaning it just has one measurement. So for example, your age, your weight, your height, those are all scalar quantities. A vector quantity has to have a magnitude and a direction. So you have to be able to measure it and then also explain what direction it's going into. So for example, velocity is a common one with speed. So I might say the car was traveling at 120 kilometers per hour and then in the direction east. Okay, force is a vector quantity because maybe we're pulling on something in a certain direction. Okay, so vector quantities have to have both a magnitude and a direction. So we represent vectors with an arrow. So this part of the vector is called the head or the tip. I usually call it the tip, and then this part's the tail. Okay, and that's important when we're putting vectors together and adding them. We always have to go tip to tail. So it's important that you know which is which. So the head or the tip points in the direction of the vector, and then the length of the vector is the magnitude. So those are the two important things about a vector. How long is it, or the length, and what direction is it going? We also can label them either by the start point and the end point. So I could call this vector AB, and I put this arrow above it. Morning. So that means I'm starting at A and going to ending at B. That's important because we have to have a specific direction. So AB is different than BA. Okay, this would be described as B to A. So that is a different vector than A to B. Okay, so start and end are important. Or you might just describe it as a single letter. So I might just say that's vector A. Okay, so that's just labeling it. So a lot of this is just vocabulary. So equal vectors have the same magnitude, so the same length, and they have to be going in the same direction. So they have to have something like this one. So these two, A and B, are equal vectors. They are going in the same direction and they have the same length. They don't have to start and end at the same point, okay? But they have to have the same length and they have to be going in the same direction. So basically they need to be parallel to be equal. Opposite vectors would have the same magnitude but opposite direction. So you might have, like the previous one, AB and then BA. Let's write this here. Do a better job here. So AB is opposite to BA. So those would be opposite vectors. They have the same length, but they're going in the opposite direction. Okay. So here's just some examples. So this A and B have the same direction, but different magnitudes. So you can see that they're parallel, but they're different lengths. So they have different magnitudes, but same direction. These two, A and B, have the same magnitude, so they have the same length, but they go in different directions. And then example 3, they have the same direction and the same magnitude or length. All right. Okay, so here I have a regular hexagon, so that means all sides are the same length. So a regular object has equal sides. So it says, give examples of vectors which are equal. So I could pick lots in here. There's lots of vectors that are equal. I could say AB is equal to ED, okay? I'm going to write it down here. So equal vectors. If I start at A and end at B, it would be equal to e to d. So when I look at that, I can see they have the same magnitude, right? They're the same length, and they're going in the same direction because they're parallel. Okay, another example might be f to b would be equal to e to c. Okay, they're going in the same direction, and they have the same length. So those are equal vectors. Another example might be c to b and e to f. So there are lots of vectors in there that are equal. Okay, B says parallel but different magnitudes. So I'm looking for two vectors that are parallel but maybe different lengths. Let's see. So these two here, E to B and D to C are parallel but different lengths, okay? E to B and D to C. C says opposite. So opposite, there's lots of examples. They just have to be going, they have to be the same length going in opposite directions. So perhaps F to B and C to E are opposite. Okay, so they are the same length but going in opposite direction. F to B, E to C. Sorry, C to E. Got that one backwards. And then D says equal in magnitude but not parallel. So you have to be the same length but not parallel. So I would say perhaps these two. Because it's a regular polygon, I know they're the same length, but they're not parallel, not going in the same direction. And then different in both magnitude and direction. Possibly be E to D and E to B are different lengths and going in different directions, okay? So that's just identifying what's what. Okay, it'll also talk about direction in bearing. There's a difference between true bearing and quadrant bearing. So true bearing is measured from north. So if you think of north, south, east, west, and it goes in the clockwise direction. So this is true bearing. Okay. So 150 degrees would be from 0 north ending up here, thinking about east as 90, right? So east would be 90 degrees, so 150 would be all the way down at the bottom. A quadrant bearing is different. A quadrant bearing measures in the quadrant measured from east, north and south line, going either east or west. Okay, so for example, if I take the same angle 150, so 150 degrees would be a true bearing. If I measured that as a quadrant bearing, I'm either measuring it from south or north, right? So south is the closest one. So I'm starting at south and I'm going towards the east. So this direction would be southeast. This direction would be southwest. This direction would be northeast, and this direction would be northwest, right? So you're either starting at north or south and either going east or west. So 150 true bearing would be south 30 degrees east. So that means I'm starting at south and I'm going 30 degrees towards the east. So that would be the same angle but quadrant bearing. Okay, so this one here, describe the vector shown in terms of true bearing and quadrant bearing. So true bearing, it's going to start at north and it's going to come all the way around to the terminal arm or the vector. Okay, so this is the vector here. So if you think of 90, 180, so from north to south, it's 180 degrees, and then an additional 25. So measured as a true bearing, it would be 205 degrees. So 180 plus 25. If I were doing it as a quadrant bearing, I am starting at south and I'm headed towards the west. So it's south 25 degrees west. Okay. So here we have a couple of examples of true bearing, and they want you to express it as quadrant bearing. So 30 degrees as a true bearing is measured from north going clockwise 30 degrees. So as a quadrant bearing, it would be north 30 degrees towards the east. We've already done 150, so let's skip over to 225. So 225 is 90, 180 all the way over here. So I have to figure out this angle here, right? This is 180. So we never measure, we're going to measure either from north or south, not from east or west. So this angle here would be 45 degrees, okay? So if I do 225 minus 180, this is the difference, right? It's 180 to here. So if this is 225 and I subtract 180, I'll be able to figure out that angle. So the quadrant bearing would be south 45 degrees towards the west. Okay? So that would be a quadrant bearing. These questions give it to you as a quadrant, and you have to write it as a true bearing. So I'm going to draw A as a quadrant, so it's starting at the south, going 40 degrees towards the east. So this is south, 40 towards the east. So if I were doing that as a true bearing, I'm going to measure from north and end up at that vector. So the true bearing would be 140, because I know it's 180 to south, so I can do 180 minus 40 will give me the true bearing. Okay, B is north 30 west. So north 30 towards the west. Okay, so that's the quadrant bearing, but remember with true bearing you have to measure from north in the clockwise direction, so we have to go all the way over there. So that would be 330. And I can calculate that by just saying, well, it's 360 all the way around, and I'm short 30, so I'll just subtract to get that true bearing. Okay? So the first part of the guide is just identifying what a vector is, being able to find equal vectors, opposite vectors, how to label them, how to do your direction in bearing, and then we're going to start looking at addition of vectors after that part. So if you are on 10 or 11, 12, You can just do the first box by identifying vectors, how to label them, how to do direction, and then next we'll look at adding them together and subtracting them. Okay.